Hello, good day. I am Michael Conrad G. Valcorza from BC2B, and I'm here to explain the ideal gas law. Question 3.82 from the book Fundamentals of Thermodynamics, 7th edition. So let's proceed. So here's the question. 1 meter cube rigid tank with air at 1 megapascal and 400 Kelvin in temperature is connected to an airline as shown in the figure 3.82. So here's the figure. So you can see here, this box is the tank, which is the volume is 1 meter cube, and this tube is the airline which is connected to the tank. So the valve is opened and air flows in the tank until the pressure reaches 5 megapascal, which point the valve is closed and the temperature inside is 450 Kelvin. So letter A, what is the mass of air in the tank before and after the process? So in letter A, we're going to compute two masses, which is the before and after. So mass in air 1 and mass in air 2. Letter B, the tank eventually cools to room temperature, which is 300 Kelvin. What is the pressure inside the tank then? So let's identify the given first. So the first, as you can see here, we have only have one volume, which is 1 meter cube. So so the volume is constant. So and the pressure one is 1 megapascal. The temperature in air 1 is 400 Kelvin, and the pressure in air 2 is 5 megapascal, and the temperature in air 2 is 450 Kelvin, and lastly the temperature in the third state, which is the room temperature, 300 K. So as you can see, as you can see here, in letter A we're going to compute mass A and mass B, and letter B the pressure in state 3. So let's solve. So from letter A, we're going to use the ideal gas law, which is the PV equals to RT, where small v is equal to the volume over mass. So let's transpose the mass to the right side. So we will gain the equation PV equals to MRT, and lastly, let's transpose this RT to the left side, so we can gain PV over RT equals M. So where R is the specific gas has its own value. So klase-klase ang value sa R. If the problem is in a mass, so let's solve on where the R the R in air is 0.287 kilojoules over kilogram times Kelvin. So you can see it in the table A5, page 760, the appendix of from the fundamentals of thermodynamics 7th edition. So let's solve. And mass in air 1 is equal to pressure in air 1 times volume over R over T1. So as we put the given, so we can gain this, which 1 MP is the pressure, 1 meter cube is the volume, and below is the R and the T. So as we calculate this, we can gain the mass in air 1 is 800.71 kilograms. So let's compute the mass in air 2. So the mass in air 2 is, we have the same formula, which is M air 2 is equal to P2 times V over R T2. So we have the same formula but different given. So we have 5 megapascal and the temperature is 450 Kelvin. So as we compute this, we can gain 38.715 kilograms in in the mass of air 2. So we we just solved the mass in air 2 in there 1. So in letter B, we have a constant volume. So we will going to use the Gay-Lussac's law, which is the P2 over T2 is equal to P3 over T3. So since given man ang kwan T3, so we're going to transpose this to the left side. So we can gain the P3 of P3 time is equal to T3 times P2 over T2. So as we put all the given, we can gain 300 Kelvin times 5 megapascal over 450 Kelvin. So makancel ning K because we have two temperatures. So by computing this, we can gain the pressure in state 3, which is the 3.33 megapascal. And that's all. Thank you.